In this lesson, we're going to take the next step with algebraic expressions. So we talked about polynomials and how you can collect like terms. Today we actually want to start using that idea to solve equations. Solving an equation is the idea that there's a value that we don't know that makes the expression true. For instance, if we have x plus 4 equals 10, the only thing that x could be, the unknown, would be 6, because 6 plus 4 is 10. There is no other combination of anything that would make that statement, that sentence, true. To solve equations, our big idea is we want to isolate the variable. That's just a fancy word for saying get x by itself. Whatever number is left on the other side, as in x equals, must be the solution to our answer. So if I get x by itself, I'm going to try and keep it as x. Whatever's left on the other side has to be the answer. How are we going to go about doing this? Well, the big idea here is the inverse operations. When we move numbers or anything from one side to another, we do the opposite operation. So if I start adding on this side of the equal sign and move to the other side, it becomes subtracting. So I saw plus 4 on the left, it would become a minus 4 on the right because it's gone across the equal sign. And similarly, if I saw a minus 10 over here and I bring it to the other side, it would become a plus 10. It does the opposite. So let's try a couple of these things. There's a sentence, x plus 7 is 10. You could probably think in your head what x has to be. But we're going to have a process we can use, so when things get more complicated, we still know how to do this. So our objective is to move things from one side to the other side and get x by itself. Well, x is not by itself right now because it says x plus 7. If I move the plus 7 to the other side, I'll get x by itself equals 10. And nothing's changed so far because I took out the plus 7. I move to the other side, it goes on the end and becomes a minus 7 because it's doing the opposite. Opposite of adding is to subtract. So it's 10 minus 7, and x is 3, which I'm hoping you would agree that 3 plus 7 is 10. So we know it's the right answer. If we look at b, I got x subtract 3. I don't want to subtract 3. I want to bring to the other side and add 3. So I get x by itself equals negative 4. Hasn't changed. At the end, we put the add 3. What's negative 4 plus 3? That's negative 1. And again, we could check it if we wanted to. And negative 1 minus 3 is indeed negative 4. Okay, pause it, try it. And we'll get x by itself. So we'll bring the minus 5 over here and add it. Okay, x plus 5, and then 8 plus 5 makes 13. Sure enough, I can check it. 13 minus 5, that makes 8. Yep, that's the right answer. And the last one, bring the minus 17 to the other side, add it, and I get x is 27. And again, you can probably figure these out in your head by just guessing and checking the numbers, but I want a process that's going to work when it gets more complicated. Okay, let's try some other things. X doesn't always have to be on the left. I made them nice. I started them the easiest way, but we can move things around a little bit. The rules don't change. We have to get x by itself. So I've got plus 5 over here. I need to move it to the other side. Now, when we moved it to the right, we always said put it at the end. Same thing when we move to the left. The 2 is already there, so put the minus, subtract 5 after it. Okay, so it's still going at the end. It just happens to look like the middle because of where the numbers are. What is 2 minus 5? That's negative 3. Okay, same thing in the next one. I want to move the 6. I move the 6 to the other side. Now here you have to think a little bit. What is the 6 right now? Well, it's a positive 6. In other words, a plus 6. So I move to the other side, I have to subtract again. So 5 take away 6 is x. What's 5 minus 6? That's negative 1. Okay, we try G. I put the x on the left again. Put it in the middle spot this time. Think about the 12. It has to move over here. So we got x by itself. What is the 12? Well, technically it's a plus 12, which means you need to subtract it. So it becomes a minus 12. And I get 2. Notice I'm not thinking about this sign, right? This is the sign that's attached to the x. It's a positive x. We just don't usually show positive signs, kind of like right here, when we know they're positive signs. And last one, move the 4 to the other side, becomes subtracting. I get -5, subtract 4. Now, I did mostly subtracting questions here, you notice, because what's the one that causes the most confusion? And when you see it's a minus sign, it's easy to become a positive sign. But the weird ones are the ones that are already positive sometimes. Okay, next idea. So we've talked about adding and subtracting. Well, we have other operations too, right? Multiplying, dividing, for instance. So we could do these by inverse operations. It would totally make sense. If I multiply on one side, I divide on the other, or divide on one side and multiply on the other. But in this case, sometimes it's easier to think of whatever I do to one side, I do to the other. For instance, if I want to get x by itself in the first case, I can divide 3 by 3 and I get 1x. Right? That's what 3 divided by 3 is, 1. Or, what do we usually show? Not 1x, we just call it x. In other words, I've got it by itself. But whatever I do to one side, I have to do to the other. So I'm going to divide this side by 3 also. So I actually get 1x is 5, or in other words, x just equals 5. I've solved it. If you want to check it, what's 3x? What does this mean when I put things beside each other? It means they're multiplying, right? So if I put it in brackets, what's 3 times 5? Well, that is indeed 15. Okay. If we tried b, I want to get x by itself, so I need to divide by -6. Well, if I divide one side, I've got to divide the other side. Okay, I'm going to ignore putting the 1 in here. I don't really need it. It doesn't make sense to put the 1 there, so we'll just call it x equals. And 18 divided by -6 is -3. Okay, here's the tricky ones. How do I get rid of a dividing by? Well, I multiply. What do I have to get rid of? I divide by -5, so let's multiply by -5. Put a -5 in front. What's going to happen with these two things? They're going to divide each other out, which is just x equals. But whatever I do to one side, I got to do the other side. And 10 times -5 is -50. And the last one there, divide by 4. So that's multiply. We know they cancel each other out. If I multiply by 4 on one side, I multiply by 4 on the other side, and x is -12. And dividing is usually the trickiest one. But it really is using the idea of multiplying, where we had 3 over 3 and we could cancel to create a 1. Okay, I'm going to give you some to try here. Let's see. We're going to play with these questions, check them out, see if they work using all the 4 operations. And notice in this case I've started getting rid of the letter x. We can use different letters. It doesn't really make a difference. A letter is just a letter, something we don't know. So let's solve and check. Okay, what's going on in the first one? I got to get r by itself. Well, I can do that if I get rid of this 13. Bring it over here. It's technically an add, so I need to subtract 19 minus 13 gives me 6. Let's see if it works. That's 13 plus 6. Yep, that's 19. I got the right answer. All right, 3m. They're stuck together. What does that mean? It means they're multiplying. So I need to divide so I can cancel them out. But if I divide one side, I have to divide the other side, and m makes 9. Let's check it. 3 times 9 is 27. Hey, I got it right. Okay, let's try c. X by itself. It's got this minus 11, so I need to move it. Right, I always stick at the end, so after the -4. What's the opposite of subtracting? That's adding. So I need to add 11. -4 plus 11 is 7. Let's see if it works. -4. What's 7 minus 11? 7 minus 11 is -4. I got it right. Try 17 here, or D here. I need to get G by itself. Right now it's multiplying. So I need to divide. If I divide one side, I divide the other side. 17 divided by 10. Well, 2 negatives make a positive, And 17 divided by 10 is 1.7. Decimal this time. Let's see if it works. Alright, what is negative 10 times negative 10 times 1.7? That's negative 17. It's the right answer. Alright, last page. Give it a try yourself. See if you can get all four. And if you did, you got this stuff mastered already. Okay, got to get k by itself. Gonna move the minus 15. Notice I said minus. It looks like a negative. Minus means the same thing. Okay, 4 plus 15 is k. K is 19. It's okay to have your letters on the right. Not a big deal. 5w. Multiplying. So I got to divide. Divide one side, divide the other side. The 0 divided by 5 is still 0. It's okay to get a 0. That's not a big deal. Just like it was okay to get decimals. They're still numbers, right? Oh, here's a weird looking one, letter G. Negative x is 9. Now, we've talked about what happens if you don't see a number. Stick a number in there. What should it be? A negative 1. If it's multiplying, I got to turn it to dividing. Negative divided by negative makes it positive. And 9 divided by negative 1 is negative 9. And the last one here, I want to get b by itself, so I got to move the 9. Write down everything I've got. What happens to the 9? Well, it's a positive, so it means I got to subtract, which makes it a minus. And negative 4 subtract 9 is negative 13. And there's some simple solving. I say simple because they're usually one step. Not because they're easy, but they are one step. Try this using the website. See if you can do it. If you're stuck with things, come see me. And then tomorrow we'll move on to the ones that have more than one step.